Hello everyone, this is Gowthami. Welcome to my YouTube channel. Thank you for your support in growing our community. This motivates me to upload more videos. Keep encouraging by sharing, liking and subscribing with your family and friends. Your help means a lot to us. Let's begin the session. We are learning a concept called p-value. What is meant by p-value here is, it is nothing but a probability value. Okay, so now just observe, I have taken a simple example, that is keyboard la irukra space bar. Okay va, இப்போ நீங்க just clear-ஆ observe பண்ணுங்க. நம்ம நார்மலா டைப் பண்ணும்போது ஸ்பேஸ் கொடுக்கும்போது யூசுவலா நீங்க எங்க டச் பண்றீங்க? The maximum area we are going to touch in this place. Yes or no? Maximum நம்ம டச் பண்றது இந்த ஏரியா தான். Rare casesல நம்ம இந்த cornersல டச் பண்றோம். Yes or no? For example, if I have pressed this space bar for 100 times, in the 100 times 80 times maximum நான் இந்த middle area தான் touch பண்ண போறேன். Maybe 20 times might be mistakenly might be touching in this place. So indirectly what I am saying, it is like a normal distribution in this way. Means you are touching this area most of the times. Where you are not touching, that place is minimum. Okay, rare touch பண்ற places என்னது minimum places. So இது பார்க்கிறதுக்கு normal distribution மாதிரி இருக்கா? So p value is nothing but the probability value. How many times you are getting touched, that is what p value. So what is the probability for this place is 80%. What is the probability when you touch these places? This place is nothing but 20%. If you're touching this place, 20%. This place is nothing but 20%. So usually it will become 120. You should not write like this. So if you are taking 80% in the middle, might be the chances of touching on the corners might be this place 10%, might be this place 10%. So when you are adding up all these things, you should be like 100%. Okay. So getting my point, what I'm saying, p value is nothing but the probability value. Okay. And now what you need to do, when you are touching 100 times, when you are pressing that key for 100 times, you are getting 80 times and 20 times. Now you need to check whether you are doing a correct thing or wrong thing. To perform this, we are going to make use of hypothesis testing. What is mean by hypothesis testing? Hypothesis testing means it will treat everything same or equal. Okay, இப்போ அது வந்துட்டு எந்த பார்ஷியாலிட்டி காட்டாது. So நீங்க எடுத்துக்கிறது, நீங்க பண்ணிருக்கிறது கரெக்டான கரெக்ட் தான், தப்புனா தப்பு தான். So just like that, it will treat everything same or equal. Okay va? So நம்ம இந்த hypothesis testing பண்ணனும்னா you should follow majorly 4 steps. In the hypothesis testing, the first thing is null hypothesis. What is mean by null hypothesis? I will explain. And second thing is alternative hypothesis. So you should follow whether your assumption is correct or not, tells by this hypothesis testing only. Hypothesis testing is nothing but assumption about the value of provided by the user. Okay, நம்ம எடுத்துக்கிற டெசிஷன் கரெக்டா இல்லையான்னு சொல்றதுதான் இந்த ஹைபோதசிஸ் டெஸ்டிங். அதுல நல் ஹைபோதசிஸ் அண்ணா என்னது, ஆல்டர்னேட்டிவ் ஹைபோதசிஸ் அண்ணா என்னது, நம்ம எடுத்துக்கிற டெசிஷன் கரெக்டா இல்லையான்னு சொல்றதுக்காக தான் நம்ம இந்த ஸ்டெப்ஸ் யூஸ் பண்ண போறோம். அதுல நல் ஹைபோதசிஸ் அண்ணா என்னது, ஆல்டர்னேட்டிவ் ஹைபோதசிஸ் அண்ணா என்னது. தேர்ட் ஸ்டெப் வந்துட்டு நம்ம பர்ஃபார்ம் பண்ணணும், எக்ஸ்பெரிமெண்ட்ஸ் பர்ஃபார்ம் பண்ணணும். எக்ஸ்பெரிமெண்ட்ஸ் பர்ஃபார்ம் பண்றதுன்னா என்னது, you have to use a tests like Z test use பண்றீங்களா, T test use பண்றீங்களா, otherwise chi square test use பண்றீங்களா, different types of test use பண்ணி experiments பண்றீங்க. So once you have done all these experiments, you need to decide whether you will accept the null hypothesis or reject the null hypothesis என்றது நம்ம ஃபைனலா டிசைட் பண்றோம். ஓகேவா? So these are the 4 steps that you need to follow here. Okay, so what is mean by null hypothesis? Null hypothesis அண்ணா என்னதுன்னா, இப்போ நம்ம வந்துட்டு யூசுவலி ஒரு few things நம்ம ரிமெம்பர் பண்ணிக்கணும். So null hypothesis அண்ணா என்னதுன்னா, இப்போ ஃபார் எக்ஸாம்பிள் நமக்கு எப்பவுமே ஒரு क्वेश्चन கொடுத்திருப்பாங்கன்னு எடுத்துக்கோங்களேன். என்ன கொஸ்டின் கொடுக்குறேன்னா, let us take I'm tossing a coin. ஒரு காயின் நான் டாஸ் பண்றேன்னு எடுத்துக்கோங்களேன். ஒரு காயினை 100 டைம்ஸ் நான் டாஸ் பண்ணிருக்கேன். இந்த 100 டைம்ஸ் டாஸ் பண்ணும்போது there is a chances of getting, might be, I'm not saying compulsory, might be getting heads for 50 times, tails for 50 times. Then only I can say that coin is a fair coin. For suppose if you are tossing for 100 times, if you are getting only heads 100 times, will you say this one as a fair coin? Definitely not. It is an unfair coin. So what I'm saying, if you are tossing 100 times a coin, if you are getting heads for 50 times or might be 30 times or might be 80 times, the rest percentage will be for head tails only. Then I can say it's a fair coin. So null hypothesis is nothing but you have to say your decision as coin is fair. And what is mean by alternative hypothesis means quite opposite to null hypothesis, that is coin is unfair. This is your assumptions. Your assumptions should be defined in the null hypothesis. Okay, if you are saying a positive thing in the null hypothesis, the negative thing should be said by the alternative hypothesis. Okay, for suppose I said that I am taking the normal distribution. So normal distribution is nothing but where it is having mu as 0. That means mu is nothing but what? Mean is 0 and standard deviation is 1. Then only I can say it is a normal distribution. Okay, so here what I'm saying, I have tossed a coin for 100 times. So in that I'm saying 50 times I got it as head. That means the possibility of the mean is 50. And I'm taking my standard deviation as, if I'm taking mean as 50 and I'm going to take my standard deviation as 10. Let us assume like that. Assume. So that means what is the formula for standard deviation? Mu plus lambda. Mu plus sigma. That is sigma. So what is the output? 60. Then 70. Then 80. So here mu minus sigma. So this is 40. This is 30. This is 20. Like this. Correct. Now, so I made 50 times. So now what I have decided here? Null hypothesis. So the coin is fair. Alternative hypothesis, the coin is unfair. So here I have did this one. So now what I'm going to do? I want to perform an experiment. When I perform an experiment, I got my heads as 30. Means when I'm tossing 100 times, I got heads for 30 times. Now you have to decide where it is going to lie this point. So now already we have learned one formula, z-score formula. What is that? X minus mu by sigma. So what is the x value now? 30. 30 minus 50 by sigma. That is what is the value? That is sigma value is 10. So minus 20 by 10. So what is the output here? So minus 2. That means minus 2 means it is going to be like this side. So 2 deviations away from the mean. So 1 deviation and this is the second deviation. Your point is going to lie here. If the experiment is nearer to the mean, then I can say that it is a fair coin. It is a fair coin. So you have to understand the definition. If you are satisfying the condition, if your condition is, if your coin is true, then what is the statement you should provide here is you should reject the null hypothesis. You should reject that is the for definition. So the null hypothesis, how it is defined means you should reject that under the assumption that is true. When your assumption is true, you should reject the null hypothesis. Okay, so that is what the statements you should provide it here. So if what I'm saying, that I have got my value as 30, that means this 30 is nearer to 50. So I can say that my coin is a fair coin. So I got my output as fair. That means this null hypothesis is true. So what is the statement that you should provide? Reject the null hypothesis. Okay, ma'am. So how can we come to know this is nearer to that one? It's okay, you can get it. How means, see, I already said that we have to use one formula called empirical formula. So what I said in first deviation, it is going to be like a 65, 67 percentage, then it should be like 95%, something 65, 97, like that, right? So it is going to be here. So two deviations means it is going to be here. So if the coin is lying in this area, then I can say that it is a fair coin. If it is out of this boundary, then I can say that it is an unfair coin. For suppose if I have taken, if I have again performing an experiment, if I got heads for 10 times, again I have performed the experiment. That time in 100 times tossing, I got heads for 10 times. Then what, where it will be now? We have to check it. Well, you know the formula. So 10 minus 50 by 10. That means minus 40 by 10. That is a minus 4. That means it is away from the 3 deviation. That means 1 deviation, 2nd deviation, 3rd deviation, 4th deviation here. Means it is this value is, our value is lying out of the 3rd deviation. That means the coin is unfair. If you are satisfying this condition, here the null hypothesis is false now. So when your null hypothesis is false, you should say that you are accepting the null hypothesis. So that is what the statement you should provide it. Understanding what I'm saying here, everyone? Yes? So this is what hypothesis testing. While performing experiments, we will make use of the z-test, t-test, and chi-square test. So when we will use z-test, when we will use t-test, when we will use chi-square test? Very simple. When you know the population mean, one thing, when you know the population mean and the population standard deviation and the population size is greater than or equal to 30, then you will make use of the Z test. When we will use T test, when don't have the population standard deviation and the n value is below the 30, then you can make use of a T test. When we will use a chi-square test, when your data is in categorical format, then you can make use of a chi-square test. Hypothesis testing, Anna, what I'm saying here, reject it. Reject when it is true. எப்போ நம்ம hypothesis testing or assumption நம்ம true or நினைச்சுக்கிறோமோ, you have to reject it. அதுவே this is for null hypothesis. அதுவே alternative hypothesis அண்ணா accept பண்ணுங்க. எப்போ? When it is a false. Means இப்போ இது true ஆச்சு என்னப்போ automatically you are accepting. That means when it is false, you should accept this one. Okay va? So null hypothesis எப்போ நம்ம என்ன ஸ்டேட்மெண்ட் கொடுக்கணும்னா, you should reject this null hypothesis when that given assumption is true. Alternative hypothesis is quite opposite to the null hypothesis. இப்போ நம்ம இதுல என்ன படிக்க போறோம்னா, the first thing here is type 1 error என்னது, type 2 error என்னது, main thing பார்க்கணும் நம்ம. So this is very much a simple concept. இப்போ let us take a simple example. Coin எடுத்துக்கோங்க. So my thing is coin is a fail. This is my null hypothesis. Okay, and the second thing is alternative hypothesis என்னது, coin is unfair ன்னு சொல்லிருக்கேன். So the very definition is very much important here. So type 1 error என்னதுன்னா, so type 1 error என்னதுன்னா, you have to remember that இங்க நம்மளுக்கு confusion matrix பத்தி தெரிஞ்சிருக்கணும். So confusion matrix will have true value. So நம்மளோட original values base பண்ணிக்கிட்டு prediction values compare பண்ணிக்கிறீங்க. So just to providing the relationship between the original values and predicted values. அதுதான் நம்ம confusion matrix, நம்ம correlation பத்தி பேசிருக்கிறோம் நம்ம. So அதுவே the confusion matrix. இங்க பாத்தீங்கன்னா என்னோட null hypothesis base பண்ணிக்கிட்டு நம்ம இங்க எழுதிருக்கிறது வந்துட்டு ஒரிஜினல், நம்மளுக்கு வந்திருக்கிறது வேல்யூஸ். இது இந்த பக்கம் எழுதிக்க போறது என்னதுன்னா ப்ரிடிக்ஷன்ஸ். ஓகே, நமக்கு வந்திருக்கிற அவுட்கம்ஸ். ஓகேவா? இங்க நான் என்ன பண்றேன்னா just write it like this. நான் இங்க null hypothesis ஓட ரெப்ரசன்டேஷன் என்னன்னா H0 ன்னு சொல்றேன். Alternative hypothesis representation வந்துட்டு H1 அண்ணா கொடுக்கலாம், HA அண்ணா கொடுத்துக்கலாம். Null is nothing but what? Empty. கரெக்டா? சோ அதுக்காக H not ன்னு கொடுத்துட்டு இருக்கேன். Alternative hypothesis means H1 ஆனா கொடுக்கலாம், He ஆனா கொடுக்கலாம். So based on these conditions நம்மளோட ஒரிஜினல் வேல்யூஸ் இங்க கொடுத்துட்டு இருக்கிறேன். So H not true ஆச்சு என்னப்போ this is உங்களோட காயின்ன்றது ஃபெயில். அதே விதமா H not is false என்னப்போ உங்களோட காயின்ன்றது unfair அன்னிட்டு. ஓகேவா? இப்போ நீங்க predictions நீங்க அக்செப்ட் பண்றீங்களா ரிஜெக்ட் பண்றீங்களான்றது இப்ப மெயின் திங். சோ predictions வந்துட்டு accept H not. Next reject H not means அது fair coin-ஆ இல்லனா unfair coin-ஆன்னு சொல்றீங்க. இப்போ என்னோட ஒரிஜினல் வேல்யூ வந்துட்டு fair coin-ஆன்னு சொல்லிட்டு இருக்கேன். உங்களுக்கு வந்திருக்கிற predictionல கூட fair coin வந்திருக்கு. So this decision is correct decision. கரெக்டா? நம்மளுக்கு ஒரிஜினலா இருக்கிறது ஃபெயர் காயின் இருக்கு. நீங்க பிரெடிக்ஷன்ஸ் பண்ணும்போது கூட ஃபெயர் காயின் வந்திருக்கு. சோ அவர் டெசிஷன் இஸ் கரெக்ட் only. இப்போ இங்க பாருங்களேன். உங்களோட காயின்ன்றது ஒரிஜினலா ஃபெயர் காயின் கிடையாது. ஆனா பிரெடிக்ஷன்ஸ்ல என்ன வந்துட்டு இருக்கு? You are telling that it is a fair coin. So is this correct decision? It's a bad decision. This is not the correct one. So எப்போ உங்களோட H not ஃபால்ஸா இருந்துட்டு நீங்க அக்செப்ட் பண்றீங்களோ okay then this type of error will call it as type 2 error. What is this one? We'll call it as type 2 error. False positive என்ன சொல்றோம்னா type 2 error ன்னு சொல்றோம். இது எல்லாமே இப்படிதான் அண்டர்ஸ்டாண்ட் பண்ணிக்கணும். ஓகேவா? you have to understand this only. definitions புரிஞ்சுக்கினீங்களா ஆட்டோமேட்டிக்கா உங்களுக்கு அண்டர்ஸ்டாண்ட் ஆகும். Type 2 error எப்ப சொல்றோம்னா when your null hypothesis false and you are accepting it, then the type of error will call it as type 2 error. So next thing, இங்க உங்களோட ஒரிஜினல் காயின் வந்துட்டு ஃபேர் ன்னு சொல்லிருக்கீங்க. உங்களோட டெசிஷன் ஒரிஜினலா நீங்க ஃபேர் ன்னு சொல்றீங்க. ஆனா நம்மளோட பிரெடிக்ஷன்ஸ்ல அது ஃபேர் காயின் கிடையாதுன்னு சொல்றீங்க. அது கரெக்ட்டா? That is not correct. That is a bad decision. So எப்ப நம்ம இங்க H not true ஆயிட்டு you are rejecting it, then I can call it as type 1 error. When your null hypothesis is true, then you are rejecting. That type of error will call it as a type 1 error. So this is what we are saying, right? That is what a type 1 error. To handle this only, we are performing different types of tests. So this place will call it as type 2 error. And this place will call it as type 1 error. அது எங்க பாருங்க உங்களோட ஒரிஜினலா நீங்க காயின்ன்றது unfair coin ன்னு சொல்றீங்க. predictionsல கூட unfair ன்னு சொல்றீங்க. So this is a correct decision. So this is what type 1 error and type 2 error. இது அண்டர்ஸ்டாண்ட் ஆச்சா எல்லாருக்குமே? So இங்க நம்ம type 1 error type 2 error ன்னு சொல்லும்போது டெஸ்ட் ஹைபோதசிஸ் டெஸ்டிங் பண்ணும்போது யூசுவலி எப்பவுமே நமக்கு நார்மல் டிஸ்ட்ரிபியூஷனே இருக்கும்னு கிடையாது. So நம்மளுக்கு நார்மல் டிஸ்ட்ரிபியூஷன் what? So it should be like this and there will be like extreme points. So these points I can call it, these areas I can call it as a critical region. So that means we are not that much our focus பண்ற தேவையில்லை இந்த ஏரியா. That is called critical regions. நம்ம mainly we will be focusing on this region, that is this is what our region. Okay, நம்ம accept பண்ற region அதுவே தான். புரியுதாமா? So region of acceptance. The corner points critical region ன்னு சொல்றோம். That means we are rejecting that areas. Yes sir. நம்மளோட coin toss பண்ணிருக்கோம். நம்மளோட coin toss பண்ணும்போது 10 heads வந்தப்ப the point is here. So will you accepting this one? No, you are rejecting this one. So that type of region will call it as a critical region. If your point is in between this region, that region will call it as region of acceptance. Region of acceptance. So when it is normally distributed, if the critical regions are equally added on both sides, then this type of test is called two-tailed test. If a critical regions are two sides, when it is possible means if it is a normal distribution, then I can call that kind of distribution as two-tailed test. When we can call it as a one-tailed test of two types actually. One tail test are of two types. One is left side and right side testing. For example, what I'm saying here is, if you are bending towards more left side, this side, so you are having more critical area in this way, critical region is in this way. So this kind of thing we can call it as one-sided. So I can say this one as a one-side tail. Okay, one tail test. I can say this one as a one tail test. This is a one tail test. Particularly, I can say it as a left tail test. Left tail test. For suppose if you are having more this side, critical area, critical region in this way, this side, this is also one tail test only. Specific right tailed test and sort of. So எப்ப நம்ம டூ டெயில் டெஸ்ட் இருக்குமோ நம்ம கிட்ட இருக்கிற வேல்யூ வந்துட்டு டூ சைட்ஸ்க்கு ஈக்குவலா டிவைட் பண்றீங்க. அதுவே ஒன் டெயில் டெஸ்ட்னு சொல்றீங்களோ அது வந்துட்டு ஒரு சைடுக்கு மட்டும் தான் நம்ம டிஸ்ட்ரிபியூட் பண்ணிக்கிறோம். நம்ம திரும்பி டிவைட் பண்ற தேவையில்லை. சோ எப்ப நம்ம டூ டெயில் டெஸ்ட் ஒன் டெயில் டெஸ்ட்னு சொல்லலாம்னா, இஃப் யுவர் population mean is denoted with the help of mu. Population mu is equal to h naught. H naught is also be represented with the help of mu naught. எப்ப நம்மளோட population mean அன்றது equal to mu naught ஆயிடுமோ, ஓகேவா, அப்போ obviously alternative hypothesis அன்றது population mean க்கு not equal to null hypothesis. Yes or no? That means population mean is not equal to null hypothesis. This is alternative hypothesis. அப்போ we can say it like a two-tailed test. One tail test எப்ப சொல்றோம், உங்களோட population mean is greater than a null hypothesis. இங்க பாத்தீங்கன்னா greater than symbol இருக்கு. That means I can say it like it is a right tailed test. If your population mean is less than mu naught, இங்க less than symbol இருக்கு, means you are having a one tail test as left tailed test. இது எல்லாமே ஃபார்முலாஸ் மா. நீங்க நான் எப்படி ஷார்ட்கட் சொல்றேனோ அதை அப்படியே மைண்ட்ல வச்சுக்கோங்க, ஈஸியா அண்டர்ஸ்டாண்ட் பண்ணிக்கலாம். எப்போ உங்களோட population mean is equal to உங்களோட null hypothesis, மீன்ஸ் அங்க கொடுத்திருக்கிற வேல்யூ உங்களோட null hypothesis ஈக்குவலா கொடுக்குறீங்களோ, then I can say it as a two-tailed test. If the value population mean is less than your mu naught, that means null hypothesis, then it is a left skew, left tail test. Greater than means a right tail test. அப்படிதான் நம்ம டிசைட் பண்ணிக்கிறோம். புரியுதா? Understanding what I said here.
Yes ma'am. Yes ma'am.
So இப்போ இது உங்களுக்கு வேணும்னா ஒரு சின்ன எக்ஸாம்பிள். இப்போ நான் சொல்லிட்டேன். இப்போ வந்துட்டு நம்மளோட இது ஆக்சுவலா இது நான் ஜஸ்ட் கெஸ்ஸிங்ல கொடுத்திருக்கிறது. சோ இது ஃபர்ஸ்ட் டிவியேஷன், செகண்ட் டிவியேஷன் நான் ஜஸ்ட் ஒரு சிக்மா இஸ் ஈக்குவல் டு 10 நான் ஒரு ஜஸ்ட் கெஸ்ஸிங்ல கொடுத்திருக்கிறது. யூசுவலி நம்ம கிரிட்டிக்கல் ரீஜன் சொல்லிருக்கோம் இல்லையா? சோ அக்செப்டன்ஸ், ரீஜன் ஆஃப் அக்செப்டன்ஸ் எங்க வரைக்கும் வரும் நம்மளுக்கு, அதுக்கப்புறமா கிரிட்டிக்கல் ரீஜன் எப்படி சொல்றோம்னா ஜஸ்ட் வித் த ஹெல்ப் ஆஃப் தீஸ் பாயிண்ட்ஸ். இந்த பாயிண்ட்ஸ் நம்ம என்னன்னு கூப்பிடுறோம்னா இன்டர்வெல் சொல்றோமா, கான்ஃபிடன்ஸ் இன்டர்வெல் சொல்றோம். So that is called confidence values. So these points we'll call it as confidence values. This complete thing we'll call it as confidence intervals. இது எப்படி ஃபைண்ட் அவுட் பண்றோம்னா யூசிங் த ஃபார்முலா. சோ நம்ம இந்த கான்ஃபிடன்ஸ் வேல்யூஸ் ஃபைண்ட் அவுட் பண்ணணும்னா ஃபர்ஸ்ட் நம்ம பாயிண்ட் ஆஃப் எஸ்டிமேட்ன்றது கான்செப்ட் தெரிஞ்சுக்கணும். என்னது பாயிண்ட் ஆஃப் எஸ்டிமேட்ன்றது ஃபைண்ட் அவுட் பண்ண தெரிஞ்சுக்கணும். இப்போ நம்ம கிட்ட ஒரு மீன், சாம்பிள் மீன் இருந்துச்சுன்னா, if you are having a sample mean, with the help of this sample mean only we can able to calculate the population mean. So what I'm saying, நம்ம கிட்ட ஒரு சாம்பிள் மீன் இருந்துச்சுன்னா அந்த சாம்பிள் மீன் யூஸ் பண்ணிக்கிட்டு தான் எஸ்டிமேட் பண்ண போறோம், பாப்புலேஷன் மீன் எஸ்டிமேட் பண்றதுக்காக. So sample mean எப்படி டினோட் பண்றோம்னா by using a x bar, okay, estimates population mean. Population is denoted with the help of mu. Usually இந்த ரெண்டு சேமான இருக்கலாம், otherwise it may be greater than population mean இருக்கலாம், it may be less than population mean இருக்கலாம். ஓகேவா? so to check these things you have to write the formula. so one வந்துட்டு நம்ம கிட்ட two types of tests ன்னு சொல்லிருக்கேன், z test, t test ன்னு சொல்லிருக்கேன். so z test எப்ப யூஸ் பண்றீங்க, t test எப்ப யூஸ் பண்றீங்க இப்ப பார்க்க போறோம். this is very much important. so just பாருங்க. இப்போ பாயிண்ட் மீன்ஸ் என்ன சொல்லிருக்கேன், x bar estimates population mean. Remember, some terminologies explain பண்ணிட்டு பாருங்க. Capital N is nothing but population, number of values in the population. Okay, population rate. Small n is nothing but a sample number. Okay, wow. Next, mu is nothing but a population mean and it. Okay, wow. Next, sigma andra population standard deviation. Then x bar anna sample oda mean and it. அதுவே small s anna sample oda standard deviation and it. So in the points, in the notations ellame mind la vechikanum. So when we will use the t test anna, when you know the population standard deviation and n is greater than or equal to 30 achana, we can make use of a z test. So what is the formula? X bar plus or minus z alpha by 2, you have to provide sigma by root n. So this formula, we can call it like a standard error. What we'll call it as standard error. Okay, va? So inge one more thing. நீங்க இத பத்தி சொல்லிருக்கீங்க, இந்த கேபிட்டல் Z என்ன Z டெஸ்ட், சிக்மா என்ன பாப்புலேஷன் ஸ்டாண்டர்ட் டிவியேஷன், n என்ன சாம்பிள் அன்னிட்டு என்ன சொல்லிருக்கீங்க. வாட் இஸ் மீன் பை சிக்மா? சிக்மா இஸ் நதிங் பட் சிக்னிஃபிகன்ஸ் லெவல். சோ இந்த வேல்யூ எங்கிருந்த வருது நம்மளுக்குன்னா டொமைன்ஸே நம்மளுக்கு ப்ரொவைட் பண்றோமா. ஓகே, டொமைன் வில் ப்ரொவைட் சம் வேல்யூஸ். ஓகே, மீன்ஸ் நம்ம கிரிட்டிக்கல் ரீஜன் சொல்லிருக்கிறோம் இல்லையா. சோ கிரிட்டிக்கல் ரீஜன் சொல்லிருக்கிறோம் இல்லையா. சோ in the critical regions oda percentage domains will provide us. So either mostly they will be providing like 1% or 5% or 10%. Mostly in the values are provide பண்றாங்க. So you should make it like a 0.01, 0.5 means you have in 100% we are making it like 1%, 5%, 10%. Now with the probability 1, you have to make it like this. So 0.01, okay, 0.5 and 0.1. Okay, wow. So these are the critical region values. So these values are provided from the domains itself. Okay, so if you know the significance value, it's very simple to tell the confidence interval, that is 1 minus sigma, that is equal to 1 minus, if I am taking 1%, the meaning that 1. So here you have to write it 1 minus sigma. So 1% is nothing but what is the meaning? 0.01. The meaning here is 99.99%. This is what region of acceptance. So in this parabola, in this normal distribution, the region of acceptance is 99.99%. And this 0.01% is equally divided this way, this place and this place also. Understanding what I'm saying? So confidence interval. So you know these values and you need to know these positions where these values you are getting, at where you are going to divide it. Yes or no? That only we should get it with the help of this formula. With the help of this formula. If you are having the standard population standard deviation, you will use this one. If you don't know the standard deviation, then we will make use of a t test. Then what is the formula? Same thing, x bar plus or minus t sigma by 2. Here s by standard root of n. So when you know the population standard deviation, we will use this one. When you don't know this, we will make use of the sample standard deviation. Okay, this is also a standard error only. This is also a standard error only. Understanding? So you should. Here, what is this plus or minus? So plus indicates you have to make, you will get two types of values. One is lower bound of CI, that means confidence interval, this value, and one more thing is upper bound of confidence interval. Two values, x plus t alpha by 2 s by root n and x bar minus t alpha by 2 s by root n. So same way this also. So these are the two tests when you are performing the hypothesis testing. This is used for experimental purpose. Getting my point? Now you are going to find out the confidence values using these formulas. Understanding what I'm saying here, everyone?
Yes, ma'am.
So the question here is, on the quants test of CAT exam, the standard deviation is known to be 100. Okay, so here, if I didn't mention anything, the meaning here is the population standard deviation is 100. A sample of 25 test taken, okay, so 25 test takers has a mean of, see, I have said that 2 points. When you want to apply t test means when you know the population standard deviation, and second thing is n greater than or equal to 0. So if anyone satisfies, it's okay. So you should not to satisfy both of them. So if you are having n less than 30 also, it's okay. But you are having a standard deviation, population standard deviation, so you can make use of it. Okay. A sample of 25 test takers has a mean of 520 score. Construct 95% CI. So confidence interval. Now I have confidence interval as a 95 percentage. Then with the help of this, we can say the significance value. That means a 1 minus what you can say. So 95% confidence interval means what is the significance value? You can say 5% is right. So in from the 100%, 95% is this area, this complete area. 5% means this will be 2.5 percentage and this will be like 2.5 percentage. Oh, sir, no. So significance value will be, the domain given here is 5%. So I'm going to give it like 0.05. Okay. Now see here, 520 z square and construct it 25% about the mean. So now try to write this one. So see here, what I'm doing here is, let's try to write the values here. So here, population standard deviation is denoted with the help of sigma. Sigma is equal to 100. And the sample, n is equal to 25. And the sample mean, that is x bar, is equal to 520. And you know the CI value, that is 95%. So with the help of this, you can calculate the significance value, that is sigma is equal to 0.05. So here we know the standard deviation, so we will make use of the z test. Okay, so what is the formula? X bar plus or minus, what is it, z alpha by 2 sigma by a root n. So to find out these values, we have to make use of the table, that is a z table. So how to see the values in the z table, I will teach it now. So now just to try to add these, try to provide these values in this formula. 520 plus or minus z 0.05 by 2. Then this is a sigma, that is 100 by a root 25. Okay, so here we already know that the mean of this normal distribution here is a 520. So you are going to get the confidence values. One is this side and then another is this side. And you know that 2.5 percentage is, that means 2.5 percentage is critical regions. We know this one. So now you need to know these points values. So where it is lying. Okay, this values we are finding it now. So just to find it out, find out it. So this value will become 0.025. Okay, so this value will become 0.025. So 100 by 5, which is nothing but a 20. Yes or no? 100 by 5, 20. So now you need to find out Z 0.025. So now you are getting this value. Now I need to find out in this region only that you are going to get this value. So you should subtract this value from 1. So 1 minus 0.025. So the value will becomes for you as 0.975. So why I made this one to 1 minus means the values that you are going to lie in this region of acceptance. So you should subtract this one from the 1. Then you have to find out Z 0.975 value. From where? From the Z table. Okay, so now how it is going to be? 520 plus Z 0.975 into this value is 20. This value is you are getting 20, this one. So here you just open the Z table and find out the value for this. Open browser. Here you search Z table. Z table. So we have negative Z score table. We have sub value. We got it 0.975, right? Can you see here? 0.975, the value.
Yes, ma'am. Yes, ma'am.
Here, 0.975. Where it is getting for us? At
This
1.9 in the row and in the column here. So how it is going to be written means 1.97. Okay. So at 1.97, you are getting this value. Okay. So what is the Z value for this 0.958 means the value is 1.97. Okay, so you just use this Z table, positive Z table only. Okay, so now you just give the value here as 520 plus or minus 1.97 20 into 20. So now just to calculate with the 520 plus 1.97 into 20, 520 minus like that. So the lower value you will get it as something like when you are using the minus symbol between those values, you are going to get something like 480.8. When you are using the upper plus value between these values, you are going to see the output as 559.2. That means one value is just below here. That means somewhere, that means this point I can call it as 580.8. And this value is here what? 559.2. So we come to know how to calculate the this confidence values using the z-test. Same way you can calculate with the help of t-test when there is no standard deviation. If I remove this standard deviation and I have provided something like a standard deviation for a sample. For now, I'm just providing standard deviation for the sample as 80. Now, here you are not having standard deviation for population. Now you are having standard deviation for sample. Then what is the formula you will use? T-test formula. That's it. You'll make use of a t-test formula by giving the for this value s by a root n. So now how to check the when you are using G table, the value at 0.975 is 1.97. You got it. How to check the t value at the t table that we are going to see now. So same thing. So just one thing changed here is I just removed a standard deviation there. Population standard deviation I just removed and I just added sample population. So now try to elaborate the formula. Now see here. Just write the values. So n is equal to 25. Sample standard deviation is written by small s, that is 80. And the mean is a 520. And we obviously know the confidence interval is 95%. The meaning here is sigma is a 0.05. Okay, so now try to implement it with the help of a t-test now. So what is the formula? X bar plus or minus t alpha by 2 s by a root n. X bar is 520 plus or minus t 0.05 by 2. S is nothing but 8 by a root 25. So the first point you need to remember here, whenever you are testing the t-test, you should find out the degree of freedom. You should find out the degree of freedom. What is the formula for degree of freedom is n minus 1. You should provide a n is must and should. Whenever you are performing the t-test, must and should find out the degree of freedom. Okay, so with respect to this degree of freedom only, you can able to calculate the t value from the t table. Okay, so now n minus 1 is nothing but what is the n value we have already here? 25. 25 minus 1 is what value? 4. So now just write the value here, 24. 25 minus 1 is 24. With respect to degree of freedom only, we are going to calculate the value here. So 520 plus or minus t 0.025. So with respect to this degree of freedom, we are going to check the value based on this value. That means the degree of freedom will be on twice, and this is sigma value. That means sigma 2y value is 0.025. So you need to calculate the t table. So just 80 by 5. So open the t table now. So you have to check this value. So open the t table now. Just to search for t table. So any table you can take it, no problem. Here, the degree of freedom is 24. Aprama sigma by 2 value another 0.025. So in the row, so in the column, in the row, varra value another 0.263. So what is the value for this one is 2.0639. So I can make it like 2.064. I can make it. Yes or no? Because 39 I made it as 4. So the value for 24 with respect to degree of freedom, the confidence interval, that means significance value 0.025, the value is 2.064. So now try to use that. So the value for this is 2.064. So calculate this. 520 plus or minus 2.064, 80 by 5. So when you calculate this lower bounds of confidence level, you are going to get the value as 486.97. At the same way, upper bounds, okay, upper bound you will get it as something like 553.024. So if you observe the previous one and this one, little bit similar to each other. So if the mean is here, and I have made the critical regions as these regions, I need to know from where the critical region starts. These points. This point values will be like 486.97, and this value will be 553.02. From that place to rest, after that are all critical regions only. From this place to below this are all the critical regions. Between these region, I can call it as acceptance. Okay, region of acceptance. Okay, if the values or whenever you are performing the experiment, that values are between these range, then those things I can call it like what? Perfect one. Okay, so this is what Z test and T test. Is it clear? Understand, everyone? So the next thing that we are going to see here is one sample T test. இப்போ நம்ம எக்ஸ்பெரிமெண்ட் பர்ஃபார்ம் பண்ண போறோம். நம்ம எடுத்துக்கிற டெசிஷன் கரெக்டா தப்பான்னு சொல்றதுக்காக I am just going to perform one sample Z test அன்னிட்டு perform பண்ண போறேன். ஓகேவா? So one sample Z testல already I explained here. Z test அண்ணாவே we need to know நம்மளோட population standard deviation தெரிஞ்சிருக்கணும். அடுத்தது n greater than or equal to 30 ஆயிருக்கணும். இப்போ நம்ம கொடுத்திருக்கிற क्वेश्चन Z test யூஸ் பண்ணி நீங்க உங்களோட assumption ரிஜெக்ட் பண்றீங்களா அக்செப்ட் பண்றீங்களான்றது தான் சொல்லணும். சோ அதுக்கு நான் 4 ஸ்டெப்ஸ் சொல்லிருக்கேன். ஃபர்ஸ்ட் ரிமெம்பர் நல் ஹைபோதீசிஸ்ல எந்த மாதிரி அசம்ப்ஷன் எடுத்துக்கணும்னா நம்ம क्वेश्चनல என்ன கொடுத்திருக்கோமோ தட் இஸ் அவர் ஸ்டேட்மெண்ட் இன் தி நல் ஹைபோதீசிஸ். செகண்ட் திங் வந்துட்டு அதுக்கு ஆப்போசிட்டா கொடுக்கிறது தான் ஆல்டர்னேட்டிவ் ஹைபோதீசிஸ். தேர்ட் திங் என்ன பண்றீங்கன்னா you are performing a significance value. Significance value அன்றது நம்மளுக்கு டொமைன் கிட்டல இந்த வருது. If you know the CI value, confidence interval value வந்துச்சுனப்ப you can able to come to know the significance value also. Fourth thing என்னதுன்னா you have to provide the decision rule. What is the decision rule? நம்ம எக்ஸ்பெரிமெண்ட் பண்றோம் இல்லையா, that is what the decision rule. That means you are applying the Z test formula. And fifth thing நம்ம என்ன பண்றோம், you have to calculate the Z test statistics. So provide decision rule means the value means whenever you are applying the significance value or the Z table in the values தெரிஞ்சுக்கோங்க. So means அந்த பாயிண்ட் எங்க லை ஆகுதுன்னு தெரிஞ்சுக்கோங்க. fifth thing வந்து Z test apply பண்ணுங்க. sixth stepல வந்துட்டு நீங்க conclusion கொடுங்க. means state your decision. உங்களோட decision கரெக்ட்டா தப்பான்றத சொல்லிடுங்க. ஓகேவா? So இப்போ என்னோட question என்ன ஆகுதுன்னா, in the population the average IQ is, in the population average IQ means what I'm saying, population ஓட mean சொல்லிட்டு இருக்கேன். That means mu is equal to 100 ன்னு சொல்லிட்டேன். With the standard deviation of 15, population standard deviation கூட 15 ன்னு கொடுத்துட்டேன். Researchers want to test a new indication to see if there is 15 positive or negative effects on intelligence. So, or no effect at all. அவங்க என்ன சொல்லிட்டு இருக்காங்க, இந்த 100ல IQ லெவல் ரொம்ப ஆயிருக்கா கம்மி ஆயிருக்கா டெஸ்டிங் பண்ணும்போது செக் பண்ண சொன்னாங்க. ஓகேவா? So that means you don't know அது எந்த பக்கம் போ, ஒன் டெயில் டெஸ்டா டூ டெயில் டெஸ்டா நமக்கு தெரியாது. ஓகேவா? சோ நம்ம இங்க என்ன பண்றோம், ஃபர்ஸ்ட் நமக்கு மியூ இஸ் ஈக்குவல், நம்ம கிட்ட பாப்புலேஷன் மீன் இருக்குன்னப்போ நல் ஹைபோதசிஸ், that means mu is equal to mu naught. That means என்னது, mu is equal to 100 அன்னிட்டு கொடுத்துறோம். சொல்லிருக்கேன். நெக்ஸ்ட் செகண்ட் ஸ்டெப் என்னது, ஆல்டர்னேட்டிவ் ஹைபோதசிஸ் வந்துட்டு mu is not equal to mu naught, that is nothing but mu is not equal to 100 அன்னிட்டு சொல்லிருக்கிறோமா. நெக்ஸ்ட் தேர்ட் திங் நான் இங்க என்ன சொல்லிருக்கிறேன்னா, who have taken the medication has mean of 140 means யார் யாரு மெடிகேஷன் மீன்ஸ் அந்த இது எடுத்திருக்காங்களோ, மீன்ஸ் அந்த சாம்பிள் மீன்ஸ் வாட் ஐ கேன் சே சப்ளிமெண்ட்ஸ் எடுத்திருக்காங்களோ அவங்களோட மீன் என்ன, சாம்பிள் மீன். Sample mean is represented x bar is equal to 140 and alpha is equal to 0.05. இப்போ alpha is equal to 0.05 கொடுத்திருக்காங்கன்னா the mean that confidence interval is 95% நமக்கு தெரிஞ்சிருக்கு. ஓகேவா? So இங்க third step is significance value. What is that one? 0.05 தெரிஞ்சிச்சு. Fourth step என்னது, provide the decision rule. Decision rule means you need to find out the z test. Z score value என்ன நமக்கு தெரியும். So z alpha by 2 is nothing but z is 0.05 by 2, that is equal to 0.025. So you have to find out 95% கண்டுக்கணும். So அதுக்காக 1.96 நம்ம அப்பவே கண்டுபிடிச்சிருக்கோம். So நமக்கு டேபிள் பார்க்கிறதுக்கு தெரியலன்னப்போ இந்த வேல்யூஸ் நீங்க மக்கப் பண்ணி வெச்சுக்கணும். அவ்வளவுதான். 0.025 நம்ம ஆல்ரெடி வேல்யூ நம்ம டேபிள்ல காட்டிருக்கேன். சோ அந்த வேல்யூ நீங்க எடுத்து வெச்சுக்கோங்க. தட் மீன்ஸ் நவ உங்களோட ஸ்டாண்டர்ட் டீவியேஷன்ல பிளைண்டா நம்ம என்ன சொன்னோம்னா, உங்களோட மீன் வந்துட்டு பாப்புலேஷன் மீன் இங்க 100 ஆச்சுன்னப்போ ஐ கேன் சே இந்த டீவியேஷன்ஸ் மீன்ஸ் இந்த 0.25 மீன்ஸ் 0.05 இருக்கு இல்லையா. சோ இந்த பக்கம் 2.5% இந்த பக்கம் 2.5 இந்த பக்கம் இருக்கலாம், டூ டெயில் டெஸ்டா இருக்கலாம் சொல்லிட்டு இருக்கிறது நான். சோ இப்போ இந்த பாயிண்ட்ஸ் வந்துட்டு z வேல்யூஸ் வந்துட்டு 1 is minus 1.96 plus 1.96. நம்ம கிரிட்டிக்கல் வேல்யூஸ் வேணும்னப்ப நாங்க கம்ப்ளீட்டா கால்குலேட் பண்ணோம். சோ பாப்புலேஷன் எடுக்கும்போது you can take it directly this z values. Fifth step என்னது, you should apply the z test. Z test formula நமக்கு ஆல்ரெடி தெரியும். Z test is nothing but z score தான். So what is the formula? Z is equal to x bar minus mu by sigma by a root, and this is the formula. So இங்க apply பண்ணுங்க. What is the x bar here? X bar is 140 minus mu value is 100 divided by sigma value is 15 divided by n value is what? So I didn't give n value. What is the value of n here? So இங்க n value on sample deviation is 30 நாங்க எழுதல. So the sample deviation is 30. So n value is a root 30. So this value will be 40 divided by 15 by root 30. So you will get the z value as approximately நம்மளுக்கு 14.60 வந்துருமா. நீங்க இந்த வேல்யூ பேஸ் பண்ணிக்கிட்டு இன்டெலிஜென்ஸ் மீன்ஸ் நீங்க மெடிகேஷன் எடுத்துக்கும் போது இன்டெலிஜென்ஸ்ன்றது இம்ப்ரூவ் ஆயிருக்கா, இன்டெலிஜென்ஸ்ன்றது கம்மி ஆயிருக்கான்னு நம்ம கன்ஃபார்ம் பண்ணிக்கணும். ஓகேவா? டிசைட் பண்ணி நம்மளோட டிசிஷன் கரெக்டா இல்லையான்னு தெரிஞ்சுக்கணும். சோ எப்படி செக் பண்றீங்கன்னா, உங்களுக்கு வந்திருக்கிற z வேல்யூ, உங்களுக்கு வந்திருக்கிற z வேல்யூ இதற்கு கம்மி போயிருந்தா ரிஜெக்டட், இதற்கு ரொம்ப போயிருந்தா தப்பு, இம்ப்ரூவ் ஆகலன்னுட்டு. சோ இப்ப பாருங்க, உங்களோட z வேல்யூ இஸ் 14.60 is greater than 1.96. So what is the meaning here? உங்களோட வேல்யூன்றது இந்த கிரிட்டிக்கல் ரீஜன்ல வந்திருக்கு. Yes or no? 14.60 is coming in this range. That means நீங்க மெடிகேஷன்ஸ் எடுத்திருக்கிறதுனால எந்த பிரயோஜனமும் இல்லை, இன்டெலிஜென்ஸ்ன்றது ரொம்ப ஆகல, அந்த category means யார் யாரு சப்ளிமெண்ட்ஸ் எடுத்திருக்காங்களோ இன்டெலிஜென்ஸ் இம்ப்ரூவ் ஆகிறதுக்காக எந்த சான்ஸ் கிடைக்கல. தட் மீன்ஸ் நீங்க ரிஜெக்டிங் த null hypothesis. Understanding what I'm saying here, everyone? So this is about one sample z test. இப்போ சேம் எக்ஸாம்பிள் நீங்க ஸ்டெப் பண்ண போறீங்க. how to perform t test, very simple. சேம் இப்போ நம்ம அப்பவே நம்ம t டெஸ்ட்க்கு ஃபார்முலா பார்த்திருக்கோம். சேம் திங். நீங்க இந்த z ல வந்துட்டு பாப்புலேஷன் ஸ்டாண்டர்ட் டிவியேஷன் கொடுத்திருக்கேன். சோ அதுக்காக நான் z ஸ்கோர் அப்ளை பண்ணிருக்கேன். இப்போ நம்ம t டெஸ்ட் அப்ளை பண்ண போறோம். அப்போ இந்த பாப்புலேஷன் ஸ்டாண்டர்ட் டிவியேஷன் இருக்க கூடாது. சேம் ஸ்டெப்ஸ் ஃபாலோ பண்றீங்க. ஆனா இதுல ஒரு ஸ்டெப் எக்ஸ்ட்ரா பண்ண போறீங்க. தட் இஸ் கால்ட் டிகிரி ஆஃப் ஃப்ரீடம் ன்றது கால்குலேட் பண்றீங்க. what is the thing you are going to calculate? In the t test la degree of freedom ன்றது கூட calculate பண்றீங்க with the help of the sample n value. So same thing நான் இங்க என்ன பண்றேன்னா I'm going to take what means I'm going to take a population mean. Population mean is represented mu is equal to 100 and n is equal to 30. Sample mean x bar is equal to 140. Sample standard deviation is equal to 20 and sigma is equal to 0.05. These are my values. So if you see carefully, there is no population standard deviation. That time I can make use of the t test. So first same thing, population mean vandirukana, what we can say, null hypothesis vandittu you can say mu is equal to 100 kuduthringa. So அதே விதமா alternative hypothesis you can say it like mu not equal to 100. Second step, first step is done, second step is done. Third step is you need to find out the degree of freedom. df is equal to n minus 1, that is a 30 minus 1, that is a 29. At the same time, you are going to calculate the significance value, which is already given. You can write it as sigma is equal to 0.05. Then fifth thing what you should do, you should find out the t value. T sigma by 2 is equal to t 0.05 by 2, that is t 0.025. Yes or no? So now here, with respect to what degree of freedom you have to check? 29. So with respect to degree of freedom, you should know the value 0.025. So how to check it? So come back to the t table. So degree of freedom is 29. Degree of freedom is 29. So can you see here df, degree of freedom, and 0.025, this one. So with respect to this, you will get the value, that is 2.0523. What's the value? 2.0523. I can make it as 2.046. I can make it. You can make 5 only, because here less than 5. That's why you should give 5 only. So the output is 2.045 with the degree 29. For significance value 0.025. Okay. So now I'm going to give the value as 2.025. 2.045. This is my value. So you calculated this one. So what's the next thing that we need to do here? The next thing we need to do here is what you have to do. So now you got this value. So in your parabola, in your normal distribution, you have to consider the value should not below this point and it should not be above this point. If the values are below and above, then you are rejecting. If the value, the t value you are getting, okay, in between this, then you are accepting it. Okay. So now you have to perform t test. What is the formula that we know here is same formula. T is equal to x bar minus mu. Here, instead of population standard deviation, we are using the sample standard deviation. Yes, sir. So what is x bar here? X bar is 140 minus 100 divided by s is 20 divided by a root 30. So obviously 40 by 20 by root 30, it will be nearly giving like 10.954. So this value is out. If it is out of it, what you are doing? you are rejecting them. You are rejecting the null hypothesis. Your t value is greater than the t score. Okay, t score value. That means minus 2.4 is not below, it is above only. So you are just rejecting the null hypothesis. You are just rejecting the null hypothesis. Yes or no, ma? If you are rejecting the null hypothesis, what is the meaning here? What is the meaning? You are accepting that when you are taking the supplements, what? If you are taking the supplements, there is an improvement in the persons. So that is what. So I already said that when H naught is a true, you should reject it. Okay. So here it is out of it. So it is out of the range means you are rejecting the null hypothesis. If you are rejecting the null hypothesis, this is a critical region, right? You are rejecting this one. So if it is critical region, so you are meaning that you are accepting it. That means who are taking the supplements, there is
There
an
is an
improvement
improvement.
in intelligence. Yes or no?
Yes, ma'am.
So that is what the meaning of a t test also. Same thing, man. Z test also same thing. If you are rejecting the Z score, if you are rejecting the critical region, the meaning that you are accepting that the person who are taking the supplements have their increase in the intelligence. So that is what a t test. So till here understood everyone.
Yes, ma'am.
So there is one more type of test called chi-square test. So when this,
Ma'am, before
ah,
that, நீங்க இந்த பைத்தான் இது கொடுத்து ஐ மீன் சென்ட் பண்ணல மேம் நீங்க வாட்ஸ்அப்ல அந்த லாஸ்ட் நம்ம அந்த சீபார்னுக்கு
ஸ்டாட்டிஸ்டிக்ஸ்
அப்புறமா
சென்ட் பண்ணல
ஆமா
இல்லையா?
ஆமா மேம் சீபார்னுக்கு
அதெல்லாம் ஒரே
அப்புறமா
வாட்டி சென்ட் பண்ணிட்டு விடுங்கம்மா.
ஓகே 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 மேம் ஓகே ஜஸ்ட் ரிமைண்ட்
ஓகே ஃபைன் ஃபைன். ஸோ இப்போ இந்த சை ஸ்கொயர் டெஸ்ட் பத்தி பேசிடுறோமா? ஸோ இந்த சை ஸ்கொயர் டெஸ்ட் எப்போ அப்ளை பண்றோம்னா நம்மளோட டேட்டான்றது கேட்டகரிக்கல் டேட்டா ஆயிருந்துச்சு அப்போ we can make use of this chi square test மா. ஸோ நம்ம எக்ஸ்பெரிமெண்ட்ஸ் பண்ணும்போது நம்ம கிட்ட இருக்கிற டேட்டான்றது கேட்டகரிக்கலா இருந்தபோது நம்ம இந்த சை ஸ்கொயர் டெஸ்ட் அப்ளை பண்ண போறோம். ஓகேவா? For suppose இப்போ நம்ம கிட்ட chi square test ஓட formula is what means it is going to be represented with this, okay, in this symbol. Chi square is equal to sigma, okay, summation, I can say summation f0. F0 is nothing but observed values minus expected values whole square by expected values. You should use this formula. Along with this, you need to find out the chi-square value from the chi-square table. So for that, you need to find out the degree of freedom also. Okay, so these are all common. First thing is define the null hypothesis. Second thing is alternative hypothesis. Third thing is degree of freedom and also sigma value, this one, significance value. Then fourth thing is you need to find out the value from the table, chi-square table. And fifth thing is you need to perform the testing based on the data. This is a categorical data, so you should apply the chi-square testing. And finally, you have to decide whether your decision is right or wrong. Okay, whether you are rejecting the null hypothesis or accepting the null hypothesis. If you are rejecting the null hypothesis, the meaning that you are true. Okay, if you are not correct, if you are accepting the null hypothesis, which is nothing but you are false, your decision is false. Okay, so now let's take a simple example. Now what I'm taking, so in a 2000 Indian census, okay, in the 2000 Indian census, the ages of the individuals, okay. So in the 2000 year, I have a one population. That means, so if it is less than 18, 20% of the population there. Okay, in between 18 to 35, okay, ages, I'm having 30% of population, and greater than 35, I'm having 50% of population, okay, ages. So less than 18%, less than 18, I'm having 20% of population, and this is in the 2000 census. Okay, so and in between 18 to 35, 30% are there, greater than 35, 50% are there. So in 2010, I just noticed that less than 18, I have noticed 121 people. Okay. And in between 18 to 35, I'm having 288 people. And in greater than 35, I'm noticed that 91 people. So here in the about 2000, I have calculated the values in the percentage. But here I have got it in the values. So now I just want to make everything like a values only. So how can you do it? Here there is a some more values, that is n is equal to 500, that is a sample value, and significance value is 0.05. So now what I need to do here is, here this table. So I just want to know, this is our, what is this one? This is our observation. Okay, this is our observation in the 2010. So what is our expectation after 10 years? In the 2000 census, in the 2000 census means I can say that in 2010, I can observe less than 18 is 121, between 18 to 35, 288, greater than 35, 91. I want to check after 10 years, what is the population present. So that can be calculated with the help of these percentages. Okay, 20% increase, 30% increase, 50% increase. You have to calculate like that. So how can you calculate these values? So you can calculate the observed values in this way. So these are all mathematics. You should know little mathematics. If you don't know the mathematics, it will be very difficult for us. Okay, that is what you have to. Yes or no? Everything is mathematics. So now you are calculating after 10 years, right? So how to calculate? So you have to take with the help of the sample. So how many people are there? 500 people. So 500 into, so 20%. So that is 0.2. Okay, 20% has increased. Okay, so 500 into 2. That is, what is the value you will get here? So you will get it as 100. Same thing, 500 into 30%, that means 0.3. So the value will be 150. Same thing from the sample, 500 into 50%, that is 0.5. So the value will be 250. So these are all expected values for me. With the help of the sample and these percentages, I have expected these values. So now you have calculated the values. So now what is the first thing? What is the null hypothesis you have to decide? You have to give the statement. So what I can say here is meets. I can say the data meets the distribution. Means I'm having an expectation that, so we are satisfying it, meets the distribution. This is my statement. In the second thing, I can say alternative hypothesis is it's quite opposite. That is, does not meet the distribution. Okay. And the third thing, you need to find out the degree of freedom. So what is the degree of freedom that you need to calculate? Here, categories. How many categories you have? Less than 18 is one category. Between 18 to 35 is second category. And this is greater than 35 is third category. So here, n is nothing but categories. N is equal to 3. So n minus 1, that is 3 minus 1, that is equal to 2. So degree of freedom is 2. And fourth one is sigma value is 0.05. And fifth thing, what you should do here, chi-square test. Means you have to find out the chi-square value. So how to find out the chi-square value? Same thing. With the help, with the respect to the DF, you have to find out this. Open the chi-square table. That means DF with respect to 2, you have to find out sigma value 0.05. So you have to find out this value. So how to find out? Open the chi-square table. Chi-square table. Some people will by heart all these values also. If you want, you can by heart it. Otherwise, you can check it. So you know to I'm just showing here, right? So you can practice by just see. So here the DF value is 2, right? So see here, the DF value is DF2 and the sigma value is 0.05. So the 0.05 is here. So the value here is something like, what is the value, ma? 5.991. So this is the value you have to take. Okay, 5.991. So our value here is 5.991. Okay, that means you are You are just taking your region as this points, minus 5.991 plus 5.991. Understanding what I'm saying here? If the value is below this, if the value is above that, you have to reject the null hypothesis. That means you are meeting the distribution on it. Okay, ma. Sixth thing, you have to perform this formula. In the value that number check pandrathu by using this formula. So every chi square is equal to summation. That means, so observed minus exception means 121 minus 100 whole square divided by expected, that is 100. So plus, adhe vidhama 288 minus 150 whole square divided by 150. Expected is 150 plus 91 minus 250 whole square divided by expected is 250. So when you calculate this one, you will get the value as something like 232. 232 point something 494. This value will be getting for you. So this value is greater than this value. So this value is going to be like here in this critical region. That means you are rejecting the null hypothesis, meaning that you are meeting the distribution. That means your expectation is getting satisfied. Understood, ma? So this is what about a chi-square test. Till here, understood, everyone? Okay, so now in today's session, we have done what is mean by p-value. Later, we have learned a hypothesis testing. In this hypothesis testing, while we're performing the experiments, we need to know what is mean by type 1 error and type 2 error. Later on, we have seen what is mean by z-test and t-test, and also we have seen a chi-square test also. So later on, we learned what is mean by two-tailed test and a one-tailed test also. And we have seen how to see the values in the tables like a Z table, T table, and chi-square table. So this is all about inferential statistics. So in the next session, we are going to implement in Python. It is very simple. Whatever we learn the formulas, that and all will not be there. So the main thing why we are learning here is whether our assumption is correct or not. That means with the help, by what is the value you are getting, you are just satisfying that value by using this hypothesis testing. That's it. Final thing that only. You can test it with the different testing formats. So this is what our class. Clear, understood, everyone?
Yes, ma'am.
Take care. Bye, everyone.
Bye.
Bye.
Hope you thoroughly understand all the concepts what we covered in this session. If you are having any doubts, comment below. Who are not subscribed to my channel, subscribe to my channel and hit the bell icon for more notifications. We'll meet you in the next video with another concept. Until then, take care. Bye-bye.